Hey everyone, let's start with question number 16, Digital Electronics, asked in GATE examination 2025, branch Computer Science and Engineering, set 1. Formula. Consider a finite state machine with one input X and one output F represented by the given state transition table. The minimum number of states required to realize this FM is. So this is question based on state reduction. So one have to follow two steps in order to find the number of states required to realize the finite state machine. So I will write those steps. First, here we are supposed to identify two or more similar states in the next state and output state. In the above table, if you see, if we observe states of, you can see here, states of G and A got repeated with the same outputs 1 and 0. The next state is G and A. G and A got the same output 1 and 0. So I will write states G and A are having the same next state and output values for all combinations of input, that is x is equals to 0 and x is equals to 1. I mean to say, if you have the next state as G and your input is 0, so here also input is 0, you will get the output as 1. Similarly, if you have the next state G here, your input is 0 and similarly, see, the output is same. You will again get output as 1. Now, if I let you know about, if you get the next state A, you will have the input 1. So what you get an output corresponding to the input 1 is 0. Now in this state, if you get A as your next state, the output corresponding to the input 1 again is same, which is 0. That's why it is said for all combinations of input, that is x and x is equals to 0 and y equals to 1. Now eliminate the H state in the state table and wherever wherever H is present, what you gonna do to replace it with D. See here, now these two states are similar, so you have to delete this state or eliminate this state, and wherever H is present, so like you can see here H is present, you have to replace it with D. So this line states, so eliminate the H state in that state table and wherever H is present to replace it with D. So these are your key points to solve or to reduce states in a FSL. Now we will solve using these steps. I will again start writing. If you can see, H is here, G and A both are same with having same outputs. Now you can eliminate this state and write D wherever H is present. So replace it and write D. Now look for the further states which are similar. G and D is not present anywhere else. F and B is present. So you can see this state, and this state. F and B are present, but their output should also be same. Here is 0 0 and here is 1 1. So we will not go further and we will not replace this state. We will look for further state which are similar. Now if you go for DC, this state and this state DC are similar. So you have to now check for output, are those similar? 0 0, yes, and 0 0. Now you have to eliminate this state and write B wherever E is present. Now further, if you see there, this state this and this are same because F and B is now here and F and B is also here with 0 0 in output and 0 0 output. So you will replace this state and write A wherever C is present. Now there is no further state which are similar. So total number of states which are present is A with different pen, A, B, D, F and G. Total there are 5 states. So answer to this question is 5. I hope you got the better understanding on finding the states in FSL. You can also draw the state diagram. I can draw the state diagram and I will request you to verify this and let me know in the comments. So I will draw the state diagram. A goes to B when input is 1, output is 0. A goes to F when input is 0, output is 0. Now B goes to D. When input is 0, output is 0. B goes to A. When input is 1, output is 0. D goes to G. When input is 0, output is 1. And D goes to A. When input is 1, output is 0. G goes to itself for 0 and 0. And G goes to D for input 1, output 1. F goes to itself when input is 0, output is 1. And F goes to B when input is 1, output is 1. So please do it by your own and verify it. I hope you got the point. This is also one of the questions asked in previous year to choose which options are correct in the reduced state diagram. This is nothing but reduced state diagram. Thank you.